Have you ever stopped to think about what's really happening inside a complex piece of software? It's almost like there's a secret conversation going on between all its different parts. Well, today we're going to learn how to listen in on that conversation using a really powerful tool called a UML sequence diagram. All right, here's our game plan. First, we're going to cover the what, the absolute basics. Then we'll dive into the how by looking at the core building blocks and a super common login example. And finally, we'll get to the why these diagrams are so useful, and just as importantly, how to avoid some common mistakes so you can hit the ground running. So what on earth is a sequence diagram? The best way to think about it is not as a static blueprint, but more like a dynamic script that your software follows, step by step. Let's break that down. At its heart, a sequence diagram is all about showing how different parts of a system talk to each other over time. It's a visual story, but the most critical part it captures is the order of events, the sequence. Because, in software, timing isn't just important, it's pretty much everything. Okay, so to read this script, you need to know the language. The good news is, the visual grammar of a sequence diagram is actually pretty simple and incredibly powerful. And it all starts with knowing who's part of the conversation. First up, we need to separate the outside world from the inside of our system. On the outside, we have the actor. That's usually us, a human user represented by that little stick figure. They're the one kicking everything off. And on the inside, we have the lifelines. These are the actual components of the system. The user interface, the database, you name it. That vertical dashed line shows that they exist throughout this whole interaction. And how do all these parts talk to each other? Well, they send messages, which we show as arrows. Now, the style of the arrow is absolutely key. A solid line with a solid arrowhead, that's a synchronous message. Think of it like making a phone call. You ask a question and you have to wait for an answer. The whole system pauses. An asynchronous message with that open line-style arrowhead is more like sending a text message. You just fire it off and move on. And finally, that dashed line is the return message. That's the answer you are waiting for on that phone call. Okay, theory is great and all, but let's make this real. We're going to use our new language to tell the story of something we all do dozens of times a week, a simple user login. For our little login story, we've got a cast of 4. First, our actor, the user. Then we have 3 internal components, our lifelines, the login UI, which is the screen the user is actually looking at, the auth controller, which is the brains of the operation, and the database, where all the user info is kept. And notice they're laid out from left to right. That's to show the typical flow of the interaction. And action. The user kicks the whole thing off by typing in their username and password and hitting that login button. This action right here is our very first message, enter credentials, sent from our user actor over to the login UI lifeline. The whole dance starts here. Next, the login UI takes those credentials and sends them over to the auth controller. See the arrow? It's a synchronous message, so right now the UI is just waiting for a response. And look at that thin rectangle that just appeared on the auth controller's lifeline. That's called an activation box. It's a really simple way to show us that the controller is now active. It's busy, it's processing, it's thinking. So now this system is at a fork in the road. Are the credentials correct or not? To show this, we use something called an alternative fragment, marked with alt. Think of this box as a visual if-then-else statement. The top half is for one outcome, like the password is valid, and the bottom half is for the other. It's how we map out decisions. And here's how that choice plays out. If the credentials check out, we follow the top path. A success message comes back, and boom, the user sees the welcome page. But if they're wrong, we follow the bottom path. A failure message gets sent back, and the UI shows an error message. The diagram just lets us see both of those possible futures at a single glance. So, okay, we can draw these neat little diagrams, but why should you actually care? Well, because this is how we turn abstract ideas into concrete, actionable plans. So, what are these good for in the real world? Well, first, they're an amazing design tool. You can map out how all your components are going to talk before you write a single line of code. They're also an incredible communication tool, creating a shared picture that both technical folks and business folks can understand. And honestly, they're a lifesaver for debugging. Just imagine, instead of spending hours hunting for a bug, you could just look at the diagram and see exactly which message never got a reply. All right, before you run off and start diagramming everything in sight, let's talk about a few common traps that can make your diagrams more confusing instead of more clear. The biggest mistake by far is adding too much detail. You're telling a high-level story, not rewriting the entire code base. Also, please don't forget those activation boxes. They make it so much easier to see who's doing what and when. Here's another tip. If your diagram starts to look like a plate of spaghetti, it's too complex. Just break it down into smaller, more focused diagrams. And a simple one to finish, always put the actor that starts the whole process on the far left. So the next time you use an app or a website, just for a second, try to imagine the sequence diagram running behind the curtain. Every click, every search, every login, it's a story being told in messages. Which kind of raises a cool question, right? What hidden conversation is your application having right now? With sequence diagrams, you now have the key to find out.